Bridging the Knowledge Gap by Gordon MacLeod of the GERAF Foundation. Hello, today I want to talk to you about the knowledge gap. Now, the knowledge gap, some of you may not be aware, but in science, typically we have unknowns that we want to get to. And many of them, to be perfectly frank, we don't even know what they are until we get there. So, you know, it's like talking about, I can't even give you a simple example off the top of my head, but if I was talking about traveling faster than the speed of light, okay, for instance, we know that the science today tells us that no, you shouldn't be able to travel faster than the speed of light. That's a speed limit. But there are people that imagine that maybe we can, and there's now science that suggests possibly there are ways of doing it. And I'm not going to talk about those examples here, but what I will say is, for example, if I use my imagination, I can think of warp drive from Star Trek or hyperdrive from Star Wars, both of which are ways in which they travel faster than the speed of light. Therefore, they cross the knowledge gap from not being able to travel fast as the speed of light to traveling fast as the speed of light. And that's the knowledge gap. And that'll occur in large aspects of science. For instance, I study star formation. I don't know how a star forms, and I can surmise, I can assume. And all of that is based on my knowledge of what I know today. So the physics I'm taught in school, my growing up around lots of lakes and whatnot and seeing snow and so on and so forth in Canada, maybe that gives me some idea how stars form, and it feeds into my knowledge. And that's my knowledge. And I'll chip away at the gap by solving small problems and filling the gap. And that's the pebbles of knowledge you can see here on the left-hand side. But that process is incredibly slow because, one, I don't know how deep the knowledge gap is, and I have to fill the gap before I can walk across it. So we want to find ways to get across the knowledge gap quickly and efficiently, and then we will reverse engineer to what we know today, or reverse science, however you want to describe it. And I come up with a simple idea, or many people have, I'm sure. It's called DOTI. Now, DOTI stands for diversity of thought and imagination. The imagination part, I've told you, you have to be able to imagine the other side. So that's clear, that's understandable. But diversity of thought's a little interesting, a little different. Diversity of thought is effectively, we bring together people from many different cultures that see problems differently. And we think about this issue that's been imagined. And we try to find solutions around that. And that generally will give us the best possibility to come up with solutions. You could do it on your own, that's a possibility as well, but it's amplified if we use diversity of thought. And what I mean by diversity of thought here, as I said, it really has to be about the mind. It's about how I think differently from somebody who grew up in rural India versus rural Africa, rural Canada. And those people in those different parts of the world all see problems a little differently. For example, if I want to count to 5 on my hand, I go 1, 2, 3, 4, 5. You can see I can count, but notice how I did it. Closed fist, back of the hand facing you. Began with my pinky. 5. Other people might start with their thumb. Yet more, other people may start with their hand open and closed. And so the point is, there's many combinations and permutations of solving the same problem. We see it from a different direction. So if you're in a culture where you start with a closed fist, you might count like this. If you're in a culture where you start with an open hand, I mean, it will be different. And not just the culture. It could be literally in your own home. In your home, your dad did it this way. Your mother did it this way. So that's the way it works, because we all think a little different. But the key is we want to find people that really truly have diversity of thought. And of course, imagination. So, we want to get across this gap. We want diversity of thought and imagination. And that will help us to catapult ourselves from this side to that side, and then we reverse engineer. Now, the second aspect of the knowledge gap that may help us is something simpler even. Serendipity. And you might ask, well, how can I mean, serendipity is great, but it's random, it's happenstance, it's luck. Yes, that's true. But you can design your apparatus for getting across the gap to maximize serendipity. So for instance, if you're an astronomer, which I am, I will do my surveys in such a way that they're random, so that I'm checking pieces of the sky, so maybe I'll find something completely randomly. So I find ways of being more random. I observe more often. The more often I observe, the more likely I am to find a new phenomenon. So someone, for example, does a survey of the entire sky at one transition. They say they discovered 25 objects in the entire sky. Okay? That's wonderful. That's one epoch of observation. That's one snapshot of the sky. That's it. So if they were to do multiple snapshots of the sky, would they find 25 every time, or would they find 21 one time and 42 the next time? And that would then change the way they understand the science they're studying. So serendipity can be built into it as well. And so the two aspects that help us to get across the knowledge gap is DOTI, diversity of thought and imagination, and serendipity. And both can be built into your experiments in order to maximize the potential to getting across this knowledge gap. This message has been brought to you by the GERAF Foundation. We thank you for listening to us, and we hope to have you watch us on another video in the future. Have a nice day.